Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, I'm back to entertain you through mathematics. This time, of course, we are in senior 6 with our unit number 4, integration. Remember, last time we were dealing with integral of trigonometric function. Remember, the kind of integral we had last time, it was the integral of this form, a cosine x plus b sine x divided by c cos x plus d sine x dx. Of course, a, b, c, d, these are real numbers, or a cos x plus b sine x plus c divided by d cos x plus e sine x plus f dx. This is a kind of integral involving a polynomial trigonometric or numerator and the denominator. Of course, we are going to continue with integral of trigonometric function, but before looking at another kind of integral of trigonometric function, let us solve or evaluate this integral so that we can continue with the next method. Okay. Follow on chalkboard. The integral, we have tangent of x. You can imagine why it is not looking like this one. But you know that sine tangent of x is equal to sine of x divided by cosine of x. Means that 4 plus 3 tangent of x is equal to 4 plus 3 times the sine of x divided by cosine of x. Means that this is 4 cosine of x plus 3 sine of x divided by cos x. Means that the integral of 1 divided by 4 plus 3 tangent of x dx, here we have a dx, this is equal to integral 1 divided by 4 cosine x plus 3 sine x divided by cosine x dx. Means that you have integral of cosine x divided by 4 cos x plus 3 sine x dx. So the integral is not different from these ones. Do you see? All right. Now, applying the previous method, we are going to evaluate this integral. Means that I have to evaluate integral of cos x divided by 4 cosine x plus 3 sine x dx. Of course, we are going to apply the methods, our previous method, which is to express the numerator in terms of denominator. Then, of course, we'll be having some coefficient. After getting those coefficients, the work will be very simple. So it means that, as we did before, cosine x, we don't have the term in sine. I can put 0 sine x equals a times my denominator 4 cos x plus 3 sine x plus b. Then derivative of this 4 cos x plus 3 sine x derivative. So to get a times 4 cos x plus 3 sine x, then plus b minus 4 sine x plus 3 cosine x, a derivative of cosine x is cosine x, derivative of cosine x is minus sine x. So we'll be having 4a plus 3b cos x plus 3a minus 4b sine x. Of course, this is cosine x plus 0 sine x. Equating the coefficient, I'll be having 4a plus 3b cosine, that is 1, and 3a minus 4b equals 0. If I multiply by 3 and 4, I'll be having 16a plus 12b equals 4. And this is 9a minus 12b equals 0. This is 25a, which is equal to 4, means that a is equal to 4 divided by 25. Then from here, 3a equals 4b. From this equation, it means that 3 times a is there, 4 divided by 25, is equal to 4 times b. As I see 4 here, and 4, it means b is equal to 3 divided by 25. So our integral becomes a plus derivative of denominator divided by the denominator, like this, dx. A is given, even b is known here, there is b. I'll be having integral of a. A is 4 divided by 25 plus 3 divided by 25. Derivative of denominator is 4 cos x plus 3 sin x, then 4 cos x plus 3 sin x, derivative, then dx, and the answer, of course, is 4 divided by 25 x plus b, 3 divided by 25, as denominator is the derivative of denominator. This will be ln of 4 cosine x plus 3 sine x, then plus the constant of integration, and you are done. Means that if we want, we can say that the integral of 1 divided by 4 plus 3 tan x dx equals 4x divided by 25 plus 3 over 25 ln of 4 cos x plus 3 sin x plus c. Is that difficult? As you have understood the first method, even this one, they are the same, so it is very simple. The same, instead of having a tangent of x here, you can have a cotangent. So you express the cotangent in terms of sine, cosine, as cotangent is equal to cosine x divided by sine x, and you come back on this kind of integral. I hope it is very clear, right? Now, today's lesson is also the integral of trigonometric function. Of course, as I had part 1 and part 2, this should be the part 3. It is integral of this form. Integral of this form where you have cosine of mx times sine nx, or sine mx times cosine nx, cosine mx and times cosine nx, and so on. What you may know, mx is different from nx, and so on. It is the case, for instance, you have integral of sine 3x cosine 2x dx. So you can take this as a, and this is b. The same, you can have integral of sine 3x times sine 2x dx. Things like that. Why not integral cosine 2x times cosine 5x dx? It is this kind of integral we have. So the method is not difficult. Senior 4, they taught you this trigonometric formula. When you have, it is very easy to demonstrate, but for the moment is not my purpose. The purpose of this lesson is just to apply this formula to evaluate this kind of integrals. Are we together? All right. Now, as you see, 2 sine A times cosine B is equal to sine of A plus B plus sine of A minus B. It's up to recognize the value of A and B. 2 times cosine A times sine B, this is equal to sine of A plus B minus sine of A minus B. 2 times cosine A times cosine B, this is equal to cosine A plus B, then plus cosine of A minus B. And the last is 2 sine A times sine B is equal to cosine of A minus B, then minus cosine of A plus B. Those are different formula you have from senior 4. So we can apply them to solve, to evaluate different kind of integrals of that form, of course. So number 1, so as example, we are going to apply this formula as they are written on chalkboard, and you are familiar with this formula from senior 4, even senior 5. So maybe even you have demonstrated them using complex numbers. Do you remember? So you can apply them. So example, integral of sine 4x times cosine 2x dx. As you see, we have one of these forms where you have sine and cosine, sine and cosine. So it means that I can take for me A to B 4x and B is 2x. So and I have 2 sine A cosine B. But the problem, the 2 which is there. Are we together? So I can make a small change. It is like a hint, but I'm not going to change my integral. So this can be like this. I can write integral of 2 divided by 2. There is no change because 2 divided by 2 is 1. Then times sine 4x times cosine 2x dx. Do you see? So this is equal to a half, then integral of 2 sine 4x cosine 2x dx. And this is given. It is like 2 sine A cosine B. 2 sine A cosine B is here. Means that this is equal to a half integral of sine A plus B. For me it is 6 4x plus 2x, then plus sine of a minus b, it means 4x minus 2x dx. I have a half integral of sine 6x, because the 4x plus 2x is sine 6x, then plus sine 2x dx. We get a standard integral. This is a half times, integral of sine ax is minus 1 over a cos x. For me, a is equal to 6. I have minus 1 over 6 cosine 6x. Even here it will be minus a half cosine of 2x, then plus c. Expanding this to be neg 1 over 12 cosine of 6x minus a quarter cosine of 2x, then plus c. And we are done with that example. That's the use of this formula you have. So let us take another example. Cosine 5x and sine 3x. Integral cosine 5x times the sine 3x dx. Integral of cosine 5x times sine x 3x dx. Do you see? Here you have cos and sine. So this can be taken as A, and this is B. It means we have integral of sine A, cosine A and the sine B dx. Of course, A, B are a function of x. It is what I have there. So which formula can you apply to evaluate this integral? We have cosine A, then sine B. Means that you have sine A plus B minus sine A minus B. Are we together? Is that clear? Oh, very nice. So it means that I have to work as I did before here. The integral will be written like 2 divided by 2. Then cosine 5x sine 3x dx. And I get a half integral of 2 cos 5x sine of 3x dx. This is a half integral of, the formula is there, right? That is sine of A plus B. It means 5x plus 3x plus sine, it is minus 5x minus 3x dx. Check the formula is correct. Yes, it is there. Minus sine of A minus B. This is a half integral of sine. This is the 8x, because 5 plus 3x is 5x, minus sine of 5x minus 3x is 2x, then dx. So we'll be having a half times, as we have a function in sine, its integral will be minus 1 over 8 cosine of 8x. So it means that I have a minus 1 over 8 cosine of 8x minus, then minus a half cosine of 2x plus c, and I get 1 over 16 cosine of 8x. This is positive, yes, that is plus 1 divided by 4 cosine of 2x plus c. Hope you are understanding what you are doing here. Is difficult? Not at all. It's very simple. Just if you know this formula, The work is very, very easy. Do you need another example? Okay. Let us have another one. Integral cosine 6x and cosine 4x. 3. Integral of cosine 6x times cosine of 3x dx. As you see, have a cosine and also cosine. So this will be A and this will be B. And you have cosine A, cosine B, things like that. And you add the two, you have the formula which is there. Which formula can you apply? You see, 2 times cosine A times cosine B is equal to cosine A plus B plus cosine A minus B. So as we did before, this will be integral of 2 divided by 2 times the cosine of 6x, cosine of 3x, dx. That is a half. Integral of 2 cosine of 6x, cosine of 3x, dx. This is a half. Integral of what? Cosine A plus B, that is 6x, plus 3x, plus cosine of 6x minus 3x, dx. Check if the formula is correct. Cosine of A plus B plus cosine of A minus B. It is what you have there, isn't it? All right. So this is a half integral of cosine of 9x plus cosine of 3x dx. A 6x minus 3x is a 3x. So this is 1 over 2. The function is in cosine, so the integral will be 1 over 8, means 1 over 9, sine of 9x plus 1 divided by 3, sine of 3x plus c, and I get 1 over 18, sine of 9x plus 1 over 6, sine of 3x plus c. I hope it is clear. 1 for you, 1 for you. But you know you are mature enough in senior 6, you don't have any time to waste. While I'm preparing my chalkboard, of course, you are writing these 3 examples in your exercise book or even your notebook for reference, isn't it? All right. So we are back to our last example or exercise if you want. It's the same. We have a sine and the sine. So it means this is A and this is B. But you know the multiplication is commutative. You can even start by sine 2x, then times cosine sine of 5x. The work is still the same. So you are going to apply the formula sine A, then sine B. So it means that you have a half integral of 2 sine 5x times sine 2x dx. And this is a half integral of what? Oh, sorry. Cosine of 5x minus 2x, then minus cosine of 5x plus 2x dx. Verify if the formula is well applied. Cosine of a minus b, 5x minus 2x, then minus cosine of 5 plus 2x, right? So this is a half integral of cosine of 3x, yes, minus cosine of 7x dx. So this is a half times 1 over 3 sine of 3x minus 1 over 7 sine of 7x plus c to get 1 over 6 sine of 3x minus 1 over 14 sine of 7x plus c. And you have done. I hope you have understood the way we are working. I can't leave you like that without a homework. So on your screen, there is a homework. We have 2 kinds of exercises. Remember last time, when we were about to finish, we didn't get the time to have a homework. So that's why I decided to mix the homework exercise for this case and the previous one. So please copy those exercises in your exercise book. Then evaluate those integrals. We shall meet next time with answers. Thank you for having me today. I hope to meet you next time. All the best.